Students, we are studying lesson number 5 and name of the topic is there heat. So before this we have studied anomalous behavior of water. Now we are going to study about different points and in that saturated air, unsaturated air, amount of water vapor content in the air, then after that absolute humidity we are going to study, and after absolute humidity we are going to study about uh, humidity and what is the role of humidity in the nature. What is the role of humidity in the nature? So percentage humidity also we are going to study. So next thing is the then white trail we are going to study. So in on the earth there is 71% water is present on the earth. 71% of water is present on the earth, and then 29% is their land. So out of 71% water, continuous evaporation of water takes place due to the sunlight, due to the heat. Continuous evaporation of water takes place, and because of that evaporation, so what happens? Air is containing water vapor, and that water vapors present in the air. So that water vapor makes air dry. That water vapors make air moist, and because of this moisture or because of this water vapor, their air is becoming moist, and this presence of this moisture is called as a humidity. Presence of this moisture is called as a humidity, and after that, so whatever water vapor contains of that particular air, there is limit for containing the water vapor. Suppose excess water vapor will take place in the air, so that excess water vapor will get converted into water droplets, and that if water vapor exceeds the limit of that particular water content or vapor contents in the air, then that air will become saturated, and because of that excess water vapor will get converted into water droplets. It will get converted into water droplets. Okay, for that example also you can take so you can say that it is saturated air. Example also you can take at 40 degrees Celsius. If temperature is there 40 degrees Celsius, and that amount of water vapor contents will be there 49 grams of the dry air without condensation. Of the dry air with 49 for 40 degrees Celsius, 49 grams of the water vapor will be present in the dry air. Vapor per kilogram of dry air without condensation. Another thing is there, if temperature is there 20 degrees Celsius, so humidity or contents of water vapor in the air depends upon temperature. So temperature will be low, then contents of that particular water vapor will be low. If temperature is high, contents of water vapor will be high. So for that two examples we have taken. So 40 degrees Celsius, then contents of water vapor in the dry air per kilogram of dry air will be there 49 grams, and if temperature is there 20 degrees Celsius, then presence of water vapor in the dry air per kilogram dry air will be there 14.7 gram. So it depends upon temperature. After that, next thing is the when you are saying unsaturated air. So amount of water vapor contains in the air, is less than its maximum limit. Then you can say it is unsaturated air. So points one time we'll see 71% of the earth is covered by water. 71% of earth is covered by water, and due to the evaporation, water vapor is always present in the air. So due to evaporation, water vapor is always in the air. It is present always in the air. So daily weather also depends upon amount of water vapor present in the air. So daily weather also depends upon amount of water vapor present in the air. Fourth point is there humidity. So presence of water vapor in the air. If a water vapor is present in the air, it makes air moist, and this moisture is called as a humidity. If a presence of water vapor in the air, it makes air moist, and this moisture is called as a humidity. So for air, there is a limit how much vapor it contains. So there is certain limit for the air to contain the amount of water vapor. So if this amount exceeds, or this amount will become more than that limit, exceeds this limit, then excess water vapor get converted to water droplets. And air containing more water vapor, is called as a saturated air. The air which contains more water vapor, it is called as a saturated air. It is containing more water vapor than its limit, maximum limit. It is called as a saturated air. Another thing is the red point in that amount of vapor needed to saturate air depends upon temperature. Amount of that particular air or amount of that particular water vapor needed to saturate the air depends upon temperature. And for that, these two examples we have taken. So if for example 40 degrees Celsius temperature is there, so of that particular air, 40 degrees Celsius temperature of that air, then it contains 49 grams of water vapor per kilogram of dry air without condensation. So condensation will not take place. And the next thing is that if temperature of the air is there 20 degrees Celsius, so amount of water vapor contains in the air will be only 14.7 gram of the dry air per kilogram of dry air without condensation, without condensing. And 11th point is the unsaturated air. Unsaturated air. So if vapor content is less than maximum limit, its maximum limit, then you can say it is unsaturated air. So after this, next point we are going to study, and that next point is their dew point temperature. Dew point temperature. So what is dew point temperature? In that dew point temperature definition we are going to study, or what is actual concept of that particular dew point temperature we are going to study. So before that, I will tell what is meant by saturated, unsaturated. So you can take one beaker. In that you are taking some amount of water, and in that you are going to add, suppose you are going to add sugar. So water is having some limit. Up to certain limit, sugar will get dissolved. Up to certain limit, sugar will get dissolved. But one condition will reach. After that condition, sugar will not dissolve. Up to certain limit, it will dissolve. But when more sugar you are adding, then one condition will reach. Sugar will not get dissolved. That excess sugar will get settle at the bottom only. It is called as a saturated solution. You are saying saturated solution. And before saturation state, it is called as unsaturated. So same thing is there in case of the air. If that limit is, amount of water vapor will become more than the limit in the dry air, then it will become saturated. And amount of water vapor present in the air, it will be less than its maximum limit, then it is unsaturated. So next point we have to see, and that one is the dew point temperature. So what is dew point temperature? In that, in the winter season you are observing, or early morning you are observing some droplets on the leaves of the plant. So if temperature of the air decreases, if the temperature of air decreases, amount of water vapor needed also decreases. Amount of water vapor needed also decreases. Needed to saturate air decreases. Temperature of air decreases, amount of water vapor needed to saturate the air decreases, and one state reaches where excess vapor gets converted into droplets. This temperature is called as a dew point temperature. It is called as a dew point temperature. So what is dew point temperature? Dew point temperature of the air, or if temperature of the air decreases, amount of water vapor needed to saturate air also decreases, and one state reaches where excess water vapor get converted into water droplets, and this temperature is called as a dew point temperature. Suppose humidity in the evening time, it is that much only, but when our early morning is reaching, at that time temperature goes on decreasing, and whatever humidity is present, that humidity, it becomes exceed than more limit or maximum limit, and that excess water vapor in the early morning, it will get converted into dew. It will get converted into water droplets. It is called as a dew. So it is simple. When temperature of the air decreases, one state or one temperature will reach. At that temperature, air becomes saturated, and excess water vapor get converted into water droplets. It is called as a dew point temperature. It is very easy. So next point is there. So amount of water vapor contained in the air. It is called as a humidity. Next point is there. What is meant by humidity? Amount of water vapor contains of the air is called humidity. It is called as a humidity. So whatever amount of water vapor is present in the air, it is called as a humidity. And the next point is there absolute humidity. Absolute humidity. So what is absolute humidity? So amount of water vapor present, or mass of water vapor present in a per kilogram of dry air, or in a fixed volume of dry air, it is called as a absolute humidity. Amount or mass of water vapor present in the per unit volume of dry air is called absolute humidity. It is called as absolute humidity. It is called as absolute humidity. So absolute humidity, amount or mass of water vapor present in per unit volume of dry air. You can say per kilogram of dry air. Per kilogram of dry air. It is 1 kilogram of dry air. It is called as a absolute humidity. So after this, next point is the percentage humidity. The percentage humidity. After that, next one is their percentage humidity. So what is percentage humidity? So it is the ratio. Percentage humidity is the ratio of amount of water vapor present in the dry air. Ratio of amount of water vapor present in the dry air to or you can say per amount of ratio of amount of water vapor present in the dry air in given volume and at fixed temperature. Given volume and temperature to amount of water vapor needed to saturate the dry air. It is called as a percentage humidity. So percentage humidity, it is the ratio of amount of water vapor present in a given volume of air and a temperature. It is the ratio of amount of water vapor present in the given volume of air and a temperature to the amount of water vapor needed to saturate the air at that temperature is called percentage humidity. It is called as a percentage humidity. So you can write the formula. Percentage humidity is equal to amount of water vapor present in the air divided by amount of water vapor needed to make it saturated, multiply by 100. So it is called as a percentage humidity. So percentage humidity is also easy concept. So after percentage humidity, we are going to study next point, and that one is the dryness and humidity. So these points you might have understood. This one is the dewpoint temperature. If temperature of the air decreases, amount of water vapor needed to saturate that particular air decreases, and one state is reaching, or one temperature is reaching, at which excess water vapor will get converted into water droplets. This temperature is called as the dewpoint temperature. Humidity, amount of water vapor present in the air, or amount of water vapor contains in the air, is called as humidity. And absolute humidity, amount or mass of water vapor present in the dry air in the per unit volume of dry air, it is called as absolute humidity. Unit of humidity is the centimeter cube per gram. Percentage humidity, it is ratio of amount of water vapor present in the air present in given volume of air and temperature. 2. Amount of water vapor needed to saturate the air at that temperature. It is called as a percentage humidity. Percentage humidity is the amount of water vapor present in the air divided by amount of water vapor needed to make it moist, to make it saturated, and multiply by 100. So next one is there. Another point is there in that feeling of dryness and humid, it depends upon water vapor or amount of water vapor contains. So feeling of dryness and humidity, it depends upon two things. You can write here. Next point, feeling of dryness and humidity or humid, it depends upon two conditions. Feeling of dryness and humid, it depends upon two conditions. First one is the amount of vapor present in the air, and second thing is the temperature of the atmosphere. If amount of water vapor present will be large, more, then it is humid. And if temperature is also low, that one also, then humidity also increases or that at that temperature. So amount of water vapor present in the air and the temperature of the atmosphere. If temperature will increase, temperature will decrease, amount of water vapor content also changes. So another thing is there, if percentage humidity is more than 60%, then air is, or what you can say, atmosphere is humid. And if percentage humidity is less than 60%, then atmosphere is dry. If it is more than 60%, then it is humid, and if it is less than 60%, then it is dry. So next thing is there, in the winter season you are observing when any aeroplane is going, during the winter season, when any aeroplane is going during the morning time or any time, at that time white trail is remaining behind. What is remaining behind? White trail remains behind. So that white trail is there of that particular smoke, and it is showing the line behind that particular aeroplane, and that particular line will be there, white trail. So next point we are going to study, and that one is there, white trail. So what is white trail? And white trail depends upon which thing, that one we have to see. So next point, white trail of the aeroplane. White trail. White trail. First thing is that during the winter season, when aeroplane is flying, at that time some lines are remaining behind, and that one you are saying white trail. So during winter, behind the aeroplane, behind the aeroplane, white trail is observed. White trail is observed. Second thing is there, during winter, air is having more moisture or humidity. Air is having more moisture or humidity. Air is having more moisture or humidity, or water vapor content is more. And temperature is low. Third point, therefore smoke and vapor content get condensed and forms white trail behind aeroplane. It forms white trail behind aeroplane. Now, next fourth point is there. If humidity is more, white trail remains for longer duration. It remains for longer duration. Fifth point is that if humidity is less, or if air is dry, then white trail disappears and sometimes does not form. Or disappears immediately. So about white trail, aeroplanes are moving, and when aeroplanes are flying, at that time during the winter, behind the aeroplane you can see white trail. So behind aeroplane you can see white trail. So, and during winter air is having more moisture or humidity and temperature is low. Therefore, smoke or water vapor get condensed and forms white trail behind the aeroplane. If humidity is more, white trail remains for longer duration. White trail remains for longer duration. And if air is dry or humidity is less, then a white trail disappears. And sometimes does not form. Disappears immediately, and sometimes white trail will not form or it will disappear immediately. So these points are important. So another one activity is given in the textbook, and that one is there. We'll take this one here. After this, so you can check either humidity is present or air, moisture is present in the air or not, or water vapor is present in the air or not. That one you can check. For checking one or simple activities there, and from that you can decide water where dry air or air contains water vapors. So one activity is there, and in that activity you have to take one glass or beaker. You take one glass, okay, and in this glass you have to take pieces of ice. In this glass you have to take pieces of ice. This one is their glass, and you are taking pieces of ice pieces, and after keeping for short duration, you will observe some droplets are getting collected on outer surface. Some droplets are getting collected on outer surface of that particular glass. Outer surface of glass. So this first activity number first. So what it suggests, water or that ice pieces are there inside the glass, but where water is collecting on the surface of glass. Water is collecting on the surface of glass. So why it is happening? Whatever moisture is present in the air, that moisture or that temperature decreases. And due to decrease in temperature here, and because of that, water vapors get condensed and they will form droplets. And here water droplets due to condensation. And this activity proves, what is the conclusion? Conclusion is there: water vapor is present in the air. This activity shows water vapors are present in the air. Second thing is there, during early morning, water droplets are seen on the glass of the vehicles. This one is also example showing water vapor is present in the air. Another thing is there, during early morning, dew is found on the leaves of plants. So all these activities, all these things, they are showing water vapor is present in the air. Water vapors are present in the air. So all these activities are showing, they are representing that water vapor is present in the air. So next point we are going to study that one. Next point is their unit of heat. In that units of heat,